For centuries, Jupiter has been misnamed. Generations of students were taught that it is a gas giant, a massive floating ball of hydrogen and helium with no real structure beneath its clouds. This image sounds simple and neat, but modern space science has revealed that it is deeply misleading. Jupiter is not truly a planet made of gas. It is a layered, dynamic world shaped by crushing gravity, immense heat, and exotic states of matter. Beneath its thin, cloudy skin lies an alien interior unlike anything found on Earth, including vast oceans of liquid hydrogen and a core region where matter behaves in ways that challenge the laws we are familiar with. Jupiter is not just big, it is fundamentally strange. A planet too large to easily comprehend. Jupiter's size does not simply stretch the imagination, it overwhelms it. It is not just the largest planet in the solar system, it is a gravitational titan that outweighs every other planet combined. More than 1,300 Earths could fit inside its enormous volume, making it less like a planet and more like a failed star. To grasp the scale, imagine shrinking Earth to the size of a grape. Jupiter would not be a melon or a football, it would be a basketball towering over it. Its immense gravity shapes the architecture of the entire solar system, steering asteroids, sculpting comet paths, and influencing the orbits of neighboring planets. Many scientists believe Jupiter has acted as a cosmic shield for billions of years, capturing or deflecting countless space rocks that might otherwise have struck Earth and altered the course of life. Yet despite this dominant role, Jupiter's true nature remained hidden for centuries. All that could be seen were its beautiful cloud bands, masking the extraordinary world beneath like a curtain drawn across a cosmic stage. Early images that raised more questions than answers. When humanity finally saw Jupiter up close in the 1970s, the planet looked like a masterpiece of cosmic art. NASA's Pioneer and Voyager spacecraft returned the first detailed images, revealing swirling bands of color, violent storms, and the massive Great Red Spot churning endlessly across its face. These pictures transformed Jupiter from a distant dot of light into a living, dynamic world. Yet the more scientists saw, the more mysterious the planet became. The images showed only the atmosphere, a thin veil compared to the planet's enormous size. It was like admiring the clouds of Earth from space, while knowing nothing about the continents, oceans, or core beneath. Jupiter appeared stunning but unreadable, a locked vault with a beautifully painted door. The planet's deep interior, where its true nature was hidden, remained completely beyond reach. Competing theories of Jupiter's birth. For decades, astronomers believed Jupiter formed around a solid core. In the early solar system, dust and rock collided and merged into larger bodies. One of these grew massive enough that its gravity pulled in enormous amounts of hydrogen and helium gas, eventually becoming Jupiter. This theory predicted a dense, rocky core buried deep beneath thick layers of gas. An alternative idea suggested Jupiter formed more like a failed star. A massive cloud of gas collapsed under its own gravity without building a solid core first. If that were true, Jupiter would be mostly layered gas with little solid structure at its center. For many years, scientists had no way to test which theory was correct. A cosmic collision that changed everything. In 1994, a rare event provided a unique opportunity. Comet Shoemaker, Levy 9, was torn apart by Jupiter's gravity and crashed into the planet in a series of massive impacts. Each collision released energy equivalent to hundreds of millions of nuclear bombs. Dark scars spread across Jupiter's clouds, visible even from Earth. NASA's Galileo spacecraft was approaching Jupiter at the time and observed the aftermath. Material from deep within Jupiter had been blasted upward, allowing scientists their first indirect glimpse beneath the clouds. One surprising discovery was the presence of far more water than expected. Jupiter was clearly not a simple ball of gas. This realization led to a new mission dedicated to uncovering Jupiter's interior. Juno and the rewriting of planetary science. That mission was Juno. Launched in 2011 and arriving at Jupiter in 2016, Juno was built to do what no spacecraft had done before: probe the planet's interior indirectly. By measuring Jupiter's gravity and magnetic fields with extreme precision, Juno could map how mass is distributed deep inside the planet, much like doctors use scans to look inside the human body. What Juno discovered shattered long-held assumptions. Jupiter was not structured the way scientists expected. Its interior was not neatly layered with a clear rocky core beneath gas. Instead, the data revealed a planet far stranger and more complex than any textbook model had predicted. Jupiter was no longer just the largest planet. It became one of the greatest unsolved puzzles in planetary science. The violent and thin cloud layer. Jupiter's visible atmosphere is surprisingly shallow compared to the size of the planet. The colorful clouds extend only about 50 kilometers deep, a thin skin on a world nearly 140,000 kilometers wide. In this layer, temperatures fall below -100 degrees Celsius. Water ice and ammonia interact to create towering storm systems and lightning far more powerful than anything on Earth. The Great Red Spot, a storm larger than Earth, is not a surface feature. It plunges hundreds of kilometers into the atmosphere, powered by heat rising from below. Even so, this dramatic weather is only the outermost shell of a far stranger world, the planet-wide ocean of liquid hydrogen. As we descend beneath the clouds, pressure increases rapidly. Jupiter's gravity compresses everything inward. Around 1,000 kilometers below the cloud tops, hydrogen gas is squeezed into a liquid. This marks the closest thing Jupiter has to a surface, though there is nothing solid to stand on. This global ocean of liquid hydrogen is the largest in the solar system. It extends roughly 20,000 kilometers deep, more than 2,000 times deeper than Earth's oceans. Jupiter may look like a gas planet from afar, but most of its volume is liquid, where hydrogen becomes metal. Going deeper still, pressure becomes millions of times greater than Earth's surface pressure, and temperatures exceed 10,000 degrees Celsius. Under these extreme conditions, hydrogen enters an exotic state known as metallic hydrogen. The electrons break free from their atoms and move through the liquid, allowing it to conduct electricity. This metallic hydrogen forms a vast layer about 40,000 kilometers thick. It is responsible for generating Jupiter's immense magnetic field, the strongest of any planet in the solar system. Jupiter is not merely a planet. It is a giant natural dynamo, powered by an ocean of liquid metal. The mystery of the fuzzy core. For decades, scientists expected to find a compact, Earth-sized rocky core beneath the metallic hydrogen. Juno did detect a core, but not the one predicted. Instead of a sharp boundary between metal and rock, Jupiter has a fuzzy core. Heavy elements appear mixed into the metallic hydrogen, creating a gradual transition rather than a solid center. This diffuse core extends across nearly half of Jupiter's radius. Rather than a solid ball, the planet's center resembles a dense soup of rock, metal, and liquid blended together under extreme pressure. No existing formation model fully explains this structure. The planet that defies its own origin story. One hypothesis suggests Jupiter experienced a massive collision early in its history with a rocky planet many times the mass of Earth. Such an impact could have shattered and mixed its core. However, computer simulations show that even after major impacts, planetary cores should eventually settle and reform. Jupiter's fuzzy core stubbornly refuses to fit expectations. This leaves scientists with a troubling conclusion. We still do not know how Jupiter formed. Why Jupiter's secrets matter. Understanding Jupiter is essential for understanding planetary systems across the galaxy. Gas giants are among the most common types of planets discovered around other stars. If we cannot fully explain Jupiter, we do not fully understand how planets form at all. Jupiter is the nearest example of a class of worlds that dominate the universe, a giant mystery in plain sight. Jupiter is not a simple gas giant. It is a planet of violent storms floating above a hydrogen ocean, beneath which lies a vast sea of liquid metal surrounding a blurred and mysterious core. It bends the rules of physics and challenges our models of planetary birth. After centuries of observation and decades of spacecraft exploration, Jupiter remains one of the greatest unsolved objects in our cosmic neighborhood. It hangs in the sky like a colossal question mark, reminding us that even in our own solar system, some worlds still keep their deepest secrets hidden. Jupiter is no longer just a gas giant. It is a layered world of storms, oceans, liquid metal, and deep mysteries that continue to challenge everything we know about planets. The more we study it, the more it proves how strange and unexplored our universe still is. If you enjoyed uncovering Jupiter's hidden reality, make sure to like and subscribe for more mind-blowing space stories.